I think we can continue with the next lecture. So let me share my screen. Can you see the presentation?
Yes.
Okay, so okay, in this part, we will talk about remotes. And we divided this lecture into two parts separated by a break. So we will see how it goes. If you need the break, then we can take the break at the middle of the presentation. Otherwise, we can continue and finish the lecture, and then you can work on the exercises. So some core concepts. So what is a remote? A remote is basically a repository, which is a version of the project that you are working on in your local resource, right? It could be a copy of your project that is over the network, or it is hosted in another machine. And then the goal is that you and your collaborators can get the changes that all of them are doing, and also that you can share your modifications with all of them. So in addition to this, a remote is a way to back up your repository. So imagine that you're working on a project, and then you are the only one that is working on that. If you do some change, then once you do that, you lose the previous version if you don't keep track of the changes, right? But if you have a copy, an entire copy of your project in a different location, then it makes the process of recovering the repository in a more convenient way, and not to lose the changes that you are trying. So up to now, how you have worked. In my case, for instance, I'm writing some project here, and this is my repository, right? But at some point, maybe I decided to collaborate with two other colleagues. And then I set the so-called remote, where I put the entire copy of the project. And in this case, the other collaborators can get the same copy, and then they can work on the project independently. And when they want, they can get the changes that I do, and I can also get the changes that they are doing, and they can also put the changes that they want to have on the remote repository. So basically, this is the language that we will use for getting the changes. We will say that we are pulling or fetching, and for putting the changes into the remote, we say that we push the changes, right? So how we can see the remotes that are available on our repository. So we can use the git remote command with the option -v to display the available remotes in the repo. So in the present case, because I clone the repository from this URL, so Git automatically puts the origin as the default, which is this URL here. But in your case, if you start with a brand new repository, which haven't been cloned, then you won't see anything here. This happens because I cloned the repository. So because here the origin is set, so Git is already prepared for the fetching, pulling, and pushing. So this is the basic remote that you will get in standard platforms like GitHub. And if you are not working with other collaborators, then it could be more than enough to have just one origin, but it will depend on your needs. So if we take a look at the git graph command that we saw yesterday, you will see that upon setting the origin, you will see besides the reference to main, you will see the origin remote, right? So a standard way to work is by using the origin remote, but there are some cases where you would need to work with more than one remote, especially if the project is large enough. For instance, in the standard packages that run in HPC, like NAMD, right? There are collaborators around the world, and all of them can get a copy. And it's not that convenient to have just one remote, because the different researchers have their own copy of the code, and they want to implement their own methods and so on. And just when the method is ready to be pushed to the main repo, they updated the main repo. Otherwise, one would prefer to work in a local remote, so to speak. So how to add a remote? We use the git remote add and the name of the remote that we want and the location. So if you have a brand new repository that you set with mkdir, as we saw previously, then you will need a location for your Git repository for your remote. In the present case, the remote is provided by this URL, right? And this can be obtained from GitHub. And the name I will use in this case is origin. And then after doing this, I see that the origin was set. But it's not the case that this needs to be a URL. It can be also a path in your local machine. For instance, if you set a folder as a remote in a local machine, then you can use just the path to this folder, and then it will be considered as the origin. That will be convenient, for instance, if your group is not that big and you don't want to put your code in public platforms. So there are different protocols for setting the remote. That could be a local, as I said. So in this case, the project is in this path in my local machine. Another protocol could be by using SSH. And here you may need to use a SSH key that we will see later on how to set it up. And also you can use the HTTP protocol, and it uses a URL address. And also there is a Git protocol that could be also implemented. So why do we need a remote? So imagine that we have 2 users only, or there could be 2 research groups that are implementing completely independent features on some software, and they are called Bob and Alice. And Bob has the initial repository that has been published in GitHub, GitLab, Bitbucket, or any other platform. And at this point, Alice says, well, I'm interested in the repository of Bob. Then Alice does the so-called forking. And in Git, you can fork. Once you open your account, you can fork by using this button here, right? And then once Alice forks, then Alice can clone her repository and start working on her repository locally, right? So another thing why you need to work with these 2 remotes, this is one and this is the so-called upstream remote, is that sometimes one doesn't have access to the main repository to the for the software. For instance, if one wants to contribute to some code, existing code, and you don't have access or you don't have permissions to push directly to this upstream repository, then it's a good idea first to fork the repository, do your changes, maybe publish the results and make it available and say that they are worth the effort to be pushed into the upstream remote. So, and in this case, you see that I'm considering just 2 remotes. I will call this upstream and the other origin, but of course there could be several remotes. And for instance, if you have a third user that also forks the repository of Bob, then you may be interested in the changes of this third user, and then you can add the third user repo as a remote as well. So if you have a second remote, in this case upstream, and the URL for the project is this one, right? Then you can use git remote add upstream, the name and the URL. And if you check again the information for remote, you will see that it contains now the origin and the upstream directory. As you see, these remotes will be used for both for fetching and pushing. So if you check with the command git graph how the log file looks like, you will see that besides now the origin information, we also get the upstream information. And of course, you will notice when you do modifications in any of these three remotes that that you get some asynchronicities, right? So at this point, because I just added the upstream and it was synchronized with the origin and with my working directory, then everything is at the same point and everything is synchronized. So how do you work with remotes? Basically, the language is pushing or fetching and pulling. And what you need is these three commands: git push, the remote name that we have seen in this case could be origin or upstream. And if you have more repos, more remotes, you can also put the name here and the name of the branch that we want to push. This command will put the changes that we do locally into the remote. The git fetch command, as the name suggests, will bring the changes that are already available in the remote into the local branch called branch name. An additional command is pulling, which is similar to fetching, but there is a difference, and we will see that later on. And basically, you pull the changes that are in the remote into the local branch called branch name. The situation is easier if you obtain your repository by cloning, because here Git will set a remote origin. And you can use the commands push, fetch, and pull by writing the origin and the name of the branch, in this case master. But the defaults in Git are to use this origin master. And because of that, you can obtain the same effect if you just type git push, git fetch, and a git pull without any argument, right? This is the default behavior in Git upon cloning. So now, what are these commands? So the command git pull brings all the changes in the branches that are in the remote, and now it tries to merge them into your local repository, right? It does two things. First, it brings the changes, and then it tries to merge them into the local repo. And merging was something that Birgitte mentioned in the previous lecture. So if you are curious about the behavior of git pull, then you can take a look at the git dir, and inside there is a config file. And in the config file, it will tell you how git pull is acting in your repository. In this case, git, when you execute git pull, then it says it will bring all the branches that are present in the remote, and it will put that in the reference. And this behavior, of course, can be modified with the git config commands, and this is just the default behavior. So git pull is a combination of two commands. First, it is a git fetch, and then, as we saw before, we need to pass the remote name and the branch name, and then it executes a git merge with the remote name and the branch name. Or simply, if you have set previously the origin and you use the defaults, then the same behavior will be obtained if you type a git fetch and git merge for the default branches. So now the command git push will send all the changes from the branches to the remote, which is the default. So the behavior of git push can be changed by using the config command. So take a look at this line, for instance, where one can set the type of pushing behavior that you want. You can either use the matching, which is the default, and it tries to match the name of the local branch to the branch in the remote. And also you can use the current for just pushing the changes in the current branch where you are working at the time of pushing. So this behavior can be altered depending on what you want. So imagine that you have a brand new branch called new. And in this case, it is recommended to push the branch just for the first time with the command git push minus with the option -u, which will be start tracking the branch in the remote. And this is equivalent to the two following command: git push origin and new, followed by branch and set upstream new origin new. So basically you are setting the upstream branch into the remote. So by doing that with the option -u, you will be able to push and pull by simply typing git push and pull without any argument. So how do you display the remote information? You can use the git remote show and the name of the remote, right? In this case, you can see the information of how the fetching and pushing is done from what URL, and also what are the remote branches that are being tracked, and also the local branches that are configured for pulling and pushing. So in this case, it's because I was using several branches, right? It looks a bit complex. So now, if you have a remote, let's say you have a upstream remote that has been added, but then you want to change the name or rename it, then you can use the command git remote rename, the initial name, and the new name. And deleting is a similar process. It's git remote or remove, and the name of the remote that you want to remove. So now let me go into a concept that is called bare repositories. And previously we saw that for tracking the the files. Git uses three stages. One is the working directory, the other is the staging area, and the third one is the repository itself. But sometimes we don't need the working directory because basically when we share the repository, we are interested just in these two parts because we don't want the local, the remote, for instance, to be modified on site. We just want the remote to sit somewhere, and then we can get the entire remote as a copy, as a fork, for instance, but nobody is sitting in that repository and make changes. So basically, in this case, we don't need the working repository, and this is called the bare repository. And for that, Git has an option. So we have seen how to create a plain repository, but in this case, we will use the option bare repository, where we first create a folder called bare.git, and then we use the option --bare. And if we want to clone a bare repository, we can use the option git clone --bare and the location of the repository. So this is convenient if you want to make your repository public and reachable to your collaborators. And in this case, you don't need the working directory. So, okay, how do you feel? Do you need a break at this point? Or should I continue and finish the lecture? Is there any questions up to now? Okay. Okay, so I will continue with the lecture, and then at the end we will have a break and the possibility of doing the exercises. So in this part, I will show you some features of GitHub. But of course, this is just the beginning. There are many features available on these type of platforms: GitHub, Bitbucket, GitLab. And there are similarities between all these platforms, but in the present case, I will show you just the GitHub and some of the features that I consider to be useful and important, although most of them are very useful. So basically, for GitHub, you need to get an account, and you go to the website github.com, and you need to sign up for an account. And once you get the account, you can see your dashboard. And here in this part, I just focus on how to set a new repository. So if you go to the left corner, then you will see the option of the repositories, and then this button here, which will tell you if you want to set a new repository. So upon clicking this button, you will see an interface where you can set the repository name, and also Git asks you if you want to set a README file, which is useful to tell your collaborators what this repository is about, and so some of the general information that is needed for this particular repository. And also there is a feature for adding a git ignore file that I discussed in my lecture previously, where you can set the files that you want to ignore just at the beginning of the repository initialization. So once you accept these recommendations, you will see the response of GitHub, and the platform is very clever. It suggests several options that you can take. For instance, if your repository is brand new, right? Or if you have an existing repository in your local machine and you want to put or push the changes into the recently created repository on GitHub. And in this case, because this is a brand new repository, I will push the changes that are already available in my local repository. So here, Git suggests the different types of protocols that you can use for adding the remote. And as we saw before, we can use the HTTP or SSH. And here, what I can do is that I can initialize a repository, right? Then I add a file, commit the file, and here is where I add the remote repository by using the SSH option in this case. And once I do that, I can push my local changes, in this case, just the README file, into the origin master, which is the remote. Also, imagine that I have an existing repository in my local directory. Then I can just add the remote as I did previously, and then set the master branch and push the origin. Another option that Git suggests is if you want to import the code from a different repository. At the time, as I took this snapshot, there was a subversion, Mercurial or TFS project. So that's also possible, importing a repository from a different platform. For the SSH protocol that we saw before, we need to set the SSH keys, and we can follow these steps here. On a Linux terminal, we type SSH key gen with this option and with your email address here. Then we can evaluate the agent, and then we add the SSH key to the agent, And then we can copy the public key that you will get in a folder called .ssh. So we will try an exercise tomorrow on how to set these SSH keys. So once you have a copy of your public key, which is this one, right? Then you can go to the settings. I will show you quickly. You can go to settings and then go to SSH keys. Let me see. No, it's here. Sorry, here in the username, go to settings and then SSH keys, and then you add here the copy of the public keys that you obtain. So paste that without any space and without any character that can be copied from your local machine. And then you can check if the key was properly added by typing these two commands, depending on the platform that you are using, Bitbucket or GitHub. So this is the place where you need to paste the SSH key that you copied. So this is one feature that I consider interesting from the GitHub platform, is where you can see the network graph, and you can see how the commits look like in a graphical way. So here is just one of my local repositories. You can see that uh, some information can be obtained from this, but this is especially important if you're working in a large project with many collaborators. And in that case, you can see how the branches look like and when some person did some changes and so on. So you can track visually um, the changes of your collaborators. So pull request, another good feature from GitHub. So imagine that you have some initial repository, as we said before. So then a second user forks the repository, right? This user start working in the locally, and the person has the changes, and this person thinks that the work is worth the effort to put in the upstream direct repository. Then what this person can do is first push the changes into the fork repository, and it's easier to do this process, pushing and fetching, because this person has the rights to push and pull. But it's not the same in all the cases into this remote, because here the developers could have some policies and they cannot allow, for instance, any change around the world for security issues, and also maybe if they accept all the changes from all the users, then the code could break at some point. So it's better just try to put the changes from Alice, right? In this case, when the changes are very useful, and also the developers are convinced that these changes are okay, right? So at this point, these two uh, 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 repositories are synchronized, and Alice can ask for a pull request here. Then Alice can say, well, Bob, I have some useful changes that I consider that you can put in the main repository of the project. So I will send you a pull request. So how do you create the pull request? You go to the Git website with your account, and then you choose the branch that you want to where you want to do the pull request, and then you also choose the branch that will be merged into the upstream directory. And then you create the pull request here. And you can also write some messages regarding the pull request and what is it about. And at this point, Bob, the one that is sitting in the upstream remote, will receive an information with the modifications that Alice did. And he sees the pull request on GitHub, right? He sees something like this. So this is a very short message, exchange of Alice, but you can specify why you consider that your pull request is worthy to put into the upstream directory. So Bob checks the changes and analyzes the code. So maybe this is not the work of one person only. Many people can take part in this analysis. And if there are no conflicts and the code runs well and it doesn't break the code, then he can merge the request from Alice. Okay, this was for pull request. Another feature that you can use on GitHub is the so-called issues. And here, imagine that you inspect some repository that is sitting in GitHub, and you discover after some analysis that there is a problem with the code. So then you go to the repository and click on the issues button, and then you can write, well, I think that this set of compilers, for instance, is not working well for with the code, and or I think that this branch can be merged with this other, or some or any other issue that you discover. Then you can submit the issue, and this will be tracked by the developers. So this is how it will look after submitting the issue, and then other developers in the group can make the comments, and they can track the issue by using the number of the issue that is present. In this case, just by typing the number 2, they will refer to that particular issue. And upon clicking that, they will open the URL for this issue. This will help you to track the evolution of an issue in a repository in GitHub. And when this issue is solved, one can close that issue and work on the other ones. So some best practices for this part regarding the GitHub. is that one need to talk with the colleagues in order to avoid duplication of work or conflicts. And also, there are some commands that we have seen in these days, especially, for instance, we saw git rebase, or when we discussed about squashing commits, and these commands could change the history, and this is not a good idea if we want to use them on branches that have been published. Regarding the pull request, it's not a good idea to accept them right away. So in general, there should be a team, developers team, that discuss the issue, and just when they consider this appropriate, they can accept or reject the pull request. So that's it from my side. We can take a break at this point of 10 minutes. What do you think? Is there any questions?